Hey, this is Greg from Orthomerica, and we're going to talk to you about MCU. So MCU stands for Measurement and Comparison Utility, and it's integrated with the eBrace system.
Log on at ebrace.orthomerica.com.
And log in with your current username and password, and you'll have full access to the MCU. And once you're logged in, you go to Cranial, and you have a couple of different options here. You can choose Measure if you have one scan to look at, and Compare if you have two scans. We're going to start with Measure. Once you're in the measurement model window, you can see all the scans that you've taken with your camera, and you can simply locate the desired scan via the search bar. And once you've found it, just click the radio button and click Measure Selected Scan. So in this next window, you can either choose an existing alignment or create a new alignment. So you would choose the first option if you're just here to print out the same report for the patient that you've done in the past and you're happy with the alignment, or if it's a new patient or you want to change the alignment or you want to practice, you would click New Alignment and give it a name, then click Next. Now I'm going to talk about some of the basic controls. The F key will bring you into full screen mode, while the Escape key will allow you to exit the full screen mode. And if you're doing your alignment, you can hold the Shift key down while you're left clicking or right clicking and dragging, and that will allow you to fine tune the alignment. So if you just need a very, very small movement of the 3D model, you hold the Shift key down while you're using your alignment tools. And if you want more gross movements, you simply just left click or right click the mouse and drag, and you'll get the bigger movements. An easier way to do the alignment is just to use the scroll wheel of the mouse and hover over the tool that you want to use and just scroll the wheel, and that will do the same movements as if you were to left click and drag on the 3D shape. Alright, now we're back to eBrace. So once you've set up your alignment session, the very next screen is the 3D model where you're going to align the shape on the axes. The first thing you want to do is bring it into full screen mode by left clicking on the gray area one time and then hitting the F key. And now that we're in full screen mode, I'm going to kind of just give you a quick overview of all the features here. So on the left side, there's the toolbar with all the alignment tools, and you can see that they're color coded with the actual X, Y, and Z axis. And on the right side, there's the viewing toolbar, and way to the right is the measurement panes. So I'm just going to walk you through the various views here. So the default view is the shaded view, and then you also have the transparent view, which I like for aligning, so you can kind of go to the superior view and you can see right through it. And I'm jumping ahead here, but you can see if it's a little bit off alignment, you can see where the Sagittal landmark is in relation to the midline. So I'll bring that back. All right, just moving on back to where we were. And then the next view is the wire mesh view. All right, and then the next one down is the point cloud view. So we'll go back to the shaded view. And then also you can change the viewing angle. So whatever side of the box is shaded, that's the view that you're going to see. So of course this is the frontal, this is the posterior view, this is the right view, this is the left view, and the vertex view. And then you can also show or hide the markers. So from the front you can see the landmarks here. If you toggle that button, the landmarks will disappear. And the same for the slice. So we can leave the slice out for now. And then of course once you're done aligning your shape, you can always save it and then print the report. And then we'll get into the details of that in a little bit. And then, you know, if you're using these alignment tools and then you kind of lose your way and you want to start over, you can always hit reset, because these translational tools can get your shape out of whack, and sometimes it's just faster rather than try to backtrack, just hit the reset button. And then just to go over the measurements here, once the alignment is locked in, you can go through the standard measurements, which have your cephalic ratio, your circumference, the RSI, your cranial vault asymmetry index. The quadrant view, the measurements are basically your areas, similar to the Star Scanner customers when you have the symmetry ratio. So it gives all the volume measurements and the length and area of each quadrant. And then also the calculated measurements. So as you may have noticed, we have multiple landmarks here. the required landmarks are the cilion and the tip of the nose, and then also the lower front earlobes on top of the ear covers. But if you want to, you can add extra landmarks. You can add the tragaeon landmarks, the excantheon landmarks, and the subnasion, and then that will allow the software to generate the facial asymmetry measurements. So if you want with any of these, you can, and also, you can toggle between the metric and the English system. But as far as any of these measurement reports, if you don't want a measurement, or if you're not utilizing the extra landmarks for these facial asymmetry measurements, you can simply left click the header and it'll deactivate those measurements. So when you print the report, they won't even show up on the report. And if you change your mind and you want them to show up, you can click the headers again and it'll reactivate them. And that's true for the headers or any of the measurements within each section. So as you see, if it's gray, it's not going to show up on the report, but if it's lit up in white, then you're definitely going to see that measurement. So we'll go back to the quadrant view. Like some people, they might like to see the symmetry ratios, but they're not necessarily concerned about showing the exact quadrant volumes. You always have the option to customize your report. And another important thing, the volume measurements, they're taken from certain levels. I'll show the cross-sectional view here. As you can see here, the volume measurements, the inferior border is at S2, the superior border is at S8. So S2 and S8 means axial level 2 and axial level 8. So the way to scroll between the different levels is just to hover over this axial button at the bottom of the screen and use that scroll wheel on the mouse and just scroll up or down. Right? So that you can tell what level you're looking at. And when you're printing a report, you want to go to level 3 to print the report. But you can always change the level that the volume measurements are taken from. Because right now, the bottom perimeter is at S2. Let me show you where that is. Just above the ears. And the superior perimeter is at S8. So pretty much right at the top of the head. Sometimes people like to go a little bit lower than the crown of the skull for the superior border. So you can change that. If you just hover over the superior border and scroll down, you can scroll down to level 6 if you want. And leave, I recommend leaving the bottom at S2 regardless. And then let's just go down to level 6 to show you what that looks like. The volume measurements are taken between those levels, and they're split up into 4 quadrants. So you can see the different lengths and areas of each quadrant. You can see the volume of each quadrant, and you can also see the symmetry ratios. All right, and then the standard measurements, we're all well aware of those, the cephalic ratio. So we have all the measurements that allow you to calculate that, and the circumference, RSI. RSI is a measurement that's kind of, exclusive to the star scanner, but now it's for the smart sock as well. For that, let me switch views here. So here there's just a couple of measurements taking place here. I haven't aligned the scan yet, but for the RSI, here's midline. So we're breaking it's a symmetry measurement. We're dividing the skull into right and left hemispheres. So you can see here there's plus and minus 30-degree diagonal measurements. But for the RSI measurement, we're taking a plus 15 and a minus 15 measurement from the origin to the outside of the shape. So in a perfectly symmetrical shape, plus 15 degrees will be equal to minus 15 degrees as far as distance in millimeters. But if there's any asymmetry, there's going to be a minor difference between one or the other. So we add up those differences around the entire hemisphere, and the final result is the RSI, the radial symmetry index. So ideally there would be 0 difference between the right and left hemispheres all the way around the shape every 15 degrees. But if there's any asymmetry, you're going to see that number high. So the goal is to be below 30 millimeters, and anything above 30 would be considered a plagiocephalic head shape. All right, moving on. So those are those. And then also the diagonal measurements, I'm going to backtrack a little bit here. The diagonal measurements can also be changed. So The default is plus and minus 30 degrees, but sometimes the flattening is seen more or less at different angles from midline. So we can hover over the negative 30 degrees and scroll that mouse wheel, and it changes the angle. And if you change the angle on one diagonal, you want to change it to the exact angle on the other, just so that you're comparing apples with apples. But you're looking for the most severe part of the flattening, and that's where you want to take your diagonal measurements from, because that's where the child is presenting with the plagiocephaly. So it's very common to kind of toggle between 30 and 45 degrees. So if you have 45 degrees here, 45 degrees here, the difference is 11 millimeters, and then I'll go back to 30. So and again, you're just hovering over that, you're not clicking, you're just hovering over it and scrolling the mouse. So now it's 13.1. So this baby is worse at plus and minus 30 degrees, so we'll leave it there. And then the CVAI, that's calculated, that from those diagonal measurements as well. All right, so that's all you need to know about the measurements, and then I'll show you the reports in a little while as well. Okay, now we're going to start aligning the shape. So the first thing you want to do is, I'm going to scroll back down to level 3. Let's see here. All right, so the first thing you want to do when you're aligning the shape is just make sure your landmarks are in the proper position. Obviously, you're putting these stickers on a moving baby, and sometimes it might be a little bit off on the baby, but it's not worth it to try to get that landmark perfect on the baby, because it just might get them upset. So you know that you can later go in the software and change the location of that landmark. So what we're going to do is click on the landmark button on the left here, and you'll see CCU. That's specific to the star scanner. Star scanner customers know that we use the Celion and the 2 trachei to create the base plane and create the basis of alignment for the scan. And with the smart socket, it's a little bit different, so we can actually do it the CCU way, and there's also another way, the default alignment. So when you're putting the landmark stickers on the Celion on the tip of the nose, that's enough to get it, get the alignment started. And you can use all these other alignment tools to get it lined up perfectly in the X, Y, and Z axis. And then that'll be your reference scan and your reference alignment, which will later be compared down the road to the future scans. All right, so as long as the Celion and the tip of the nose look like they're right straight up and down midline, then you want to go to the sagittal view. So here, I'm just going to go back to the front view. You can kind of see that the one ear is higher than the other. And if you want to align it with the CCU method, this can pose a problem, because the CCU method uses these 3 landmarks and creates a plane that is then moved parallel to the floor. So I'll just show you what happens when we press Align by CCU. So in order to do the CCU alignment, you have to place these 3 landmarks, the Celion and 2 trachei, and click CCU, and then it's going to align it. So again, see, we made that plane that's generated by these 3 landmarks parallel to the floor. And what happens is the head gets tilted. So it's very common to see, like with plagiocephalic head shapes, that one ear might be a little bit higher than the other. So we don't necessarily want to change the landmark, because that's the true anatomy of the baby, because that'll reflect on the facial asymmetry, upper facial asymmetry measurements. So what we have available to us now is the alignment tool that will allow us to rotate on the axis and leave the actual landmarks in the same position. So say for instance this tracheion, I think it's too low. I'm going to show you how to move that. So we already have CCU toggled, so whenever you're working with the measurements, you always have to make sure that's toggled down. So you'll hover over that landmark that you want to move and left click and then drag it. So I just moved it up a little bit. And then this is your gray landmark here. So in order to get this landmark here to show up, you have to put an extra landmark sticker right on the tracheion. And then also if you want to do the facial measurements, you'll have to do the excantheons, or just outside the excantheons, and you'll place your landmark just inside of that, because you don't want to put it in the baby's eye. And then also you'll put the subnasion, and then you'll have the full function of the facial symmetry software, where you'll generate all the measurements. So That's how you move a landmark. If you wanted to delete a landmark, you hover over it and right click and then delete by left clicking. If you want to add a landmark, you right click and left click to add. And then if it's brand new and you haven't named it yet, you left click and name it. So this is the trachea right. So again, it's just right click is to add or delete a landmark, and to either move or name a landmark, you have to hover over it and left click. So to move it, you hover over it, left click and drag. To name a landmark, you hover over it, left click and name the landmark. Now we'll go to the opposite view here. This one looks good, so we'll leave that. We'll go back to the front view. So now that we're sure that our landmarks are in the proper place, we can hit the CCU, and that's going to align it to the CCU method. So you don't have to do that, but that's an option. So what we want to do, a lot of times with the CCU measurement, the head is tilted forward. You can just hover over this rotate about y-axis and scroll your wheel until the shape is vertical. All right, and then you're going to go to the frontal view, and these are in alignment as we mentioned before, but I'm going to go to the transparent view and I'm going to get to the vertex view, and just to double check to make sure that that Celion landmark is right on the midline and it looks good. So if you hover over it, it'll enlarge it and make it easier to see. So once you're happy with the alignment, all you have to do is save it. Just click on the save button, and then you can generate the report. Okay, and once you click on the printer button, you have a few options. If you look over to the left here, you have the PDF and the CSV printouts. So the PDF is basically a printout of the measurements in an actual format that includes the cross-sectional view, and the CSV is just basically all the measurements that you want in an Excel spreadsheet. So, and then there's two options for each of those. It's either all or single. So all refers to all cross sections. So you can print a report for each of the 10 cross sections, or you can just print a report for whatever cross section is showing. So for the most part, you'll just print the PDF version at level 3 or the CSV version at level 3. But you know, in certain cases you want to see, kind of analyze all different levels to see exactly where the growth was. A lot of surgeons will prefer that method just to kind of track their surgeries in detail. And then no matter what you choose, you can choose to either print the standard measurements, which is the cranial vault asymmetry, the cephalic ratio, those measurements that we talked about earlier, or you can print the quad report, which has the volumetric measurements, the volumes, areas, and symmetry ratios. Or you can choose the calculated ones that are the facial asymmetry. So if you utilize the landmark stickers and you're interested in the facial asymmetry, you can include this one as well. So you can do any one of these alone, or if you select all, you'll get 3 reports. So for this case, I've generated all 3 PDF reports at level 3. So right here you can tell what level the last report was printed at. It'll tell you level 3. And this is the standard measurement report. And then this is the quadrant one with the volume measurements and the symmetry ratios. And then at the bottom, we've included the trachea and the Celion, so we have the upper facial difference, and we didn't include any of the other landmarks. So if I would have clicked on one of these headers, those measurements would have disappeared. Next, we're going to talk about the compare function of MCU. So you go back to your cranial orders page and click compare. And then we want to search for our scans that we're going to compare. So the oldest scan is going to go on the left, and then the most recent scan will go on the right. So you go ahead and choose those. And then click Compare Selected Scans. Alright, so the comparison model will be the newest scan. So you're going to choose a new comparison for that if this is your first time doing it. But if you've already aligned it and compared this scan to another one and saved it, and you just want to reprint the report, you would choose the first option, choose an existing comparison. But for this case, we're just going to name this one. And hit next. And then so for this, the reference model, which is the oldest scan of the pair, you're going to choose the alignment that you want to use for this comparison. And then just hit next. So once the reference scan loads, all you have to do is press the lock button and confirm that you're going to lock the reference alignment by clicking the check mark. And again, if you click the lock button because it's already been aligned and saved, there's no need to realign it. And then the next prompt is asking if you want to proceed without adding all the extra landmarks for the extra measurements, like the tragions and the excantheons and subnasion markers. So if you didn't do the CCU alignment, you're missing a lot of these, but you'll still get the major measurements that the insurance companies are looking for, like the cranial vault asymmetry and the cephalic ratio. But this is just another reminder, if you want to add those landmarks, you can. So when you're ready, you just hit the check mark. And now the comparison scan is activated. So our goal is to align the comparison scan over the reference model in all three planes. So you can either do it using the tools that we talked about earlier, using the translation and rotation tools up here, but an easier method is just to left click the mouse in one of the planes, the frontal, the axial, and the sagittal plane. If you left click the mouse and drag, you'll translate the shape. And once you let go of that left mouse click, it just takes a little while to register, so you're going to wait to see the final alignment. And you just want to verify that the prominent areas are lined up, make sure that it's lined up properly, and make sure there's no overlapping of the new shape inside of the original shape, because the head is not shrinking. And the other thing you can do is you can right click and drag in the shape to rotate around that particular axis. So if you notice that it's tilted, you just want to simply right click and rotate it back into alignment. Okay, now we're moving on to the axial view. So you just want to left click inside of the shape and then drag it so that the prominent areas are lined up. And again, we're just waiting for this to register. Okay, that looks good. Now we're going to move on to the sagittal view as soon as this finishes. Here the translational movement looks good. It looks like everything is within the shape and it's aligned. It just looks like it's a little bit rotated. So we're going to right click in the shape and drag it to the right. And that should bring it into alignment. Sometimes it takes a minute for that to register. All right, so now we just want to double check and make sure that this axial view is 100% accurate. So what we're going to do is change that landmark. So I'm going to click on the markers alignment. It looks like the celion is a little bit off target there. So just move that to center. And now I'm going to change my view to the transparent view, and we have a vertical reference line. And it looks like these are following that vertical reference line, so I'm happy with that alignment. So then I'll go back to the shaded view there. And we can even go to the top view. So there you can see the before and after. Alright, so now that the alignment is set, all you have to do is hit save. And the comparison is saved successfully. And then you can print your report as you did before on the single report, and that's all there is to it.